So let's look at this equation right here. The square root of 4x plus 13 equals x plus 4. First step is to do what? Isolate the radical. The radical is already done. It's already by itself. So then I do what? Apply the power property, which means what?
Square root of 4x plus 13 squared.
Yeah. But is that all I do? Just square that side and move on? Now I understand what you just said. You said square the other side, right? Which means you square that side. You don't square each term, you square that whole side, which is different.
That's what I said, right?
No, it is what you said. I'm just emphasizing.
Oh, okay.
You said that, and we're going to do exactly what you said because what you said is right.
So if you square x,
If I square the square root, because that's what it sees first, what happens here on the left?
4x plus 13.
That's 4x plus 13. On the right side, though, there's nothing to protect x plus 4, is there? So this kind of goes back to what you saw in 0308, squaring a binomial.
I got that squaring a binomial.
Say again? And see, this is where we always screwed up in 0308. We always forget that middle term, right? When you have a binomial that's squared, a lot of times students will say a squared and b squared, but remember,
A plus b.
the 2ab part in the middle, that is the part that we always forget. And if you happen to forget that, then maybe you need to take this guy over here to the side and say, you know what? That really means x plus 4 times x plus 4. I don't want to do that because I learned my special products when my teacher taught me the special products and said, you need to know this. And I said, okay. So I kind of expect you guys to learn the special products and to use them appropriately. So when I square this, I do get x squared. I do get 16, but there's also that middle term. What is it?
8x.
I get 8x. Remember, it's a times b, and then you double that. Because if we were to FOIL this, we get 4x, not just once, but what? Twice. So if you double 4x, you get 8x. Now look at the equation that I have. What will I do here to solve this guy?
Jesus.
I need to set it equal to 0 because this is a quadratic equation. So how do I do that? Move all of that stuff over, right? Yeah, use that zero factor theorem. So 0 equals x squared, then what?
2x.
Nope.
Plus 2x.
Plus 4x.
Plus 3.
What do you mean plus 4x?
What do you mean plus 2x?
I mean, 8x minus 4x
Uh-huh.
is 2x.
Say that again.
8x minus 4x, 8x. No, 8x minus 4x. Oh, it's 4x.
Subtracting, not dividing.
Never mind.
It's all right. I mean, it's 5 o'clock in the morning. It's bound to happen. Now that I've got this equal to 0, I use f as factor, right? I use the factor theorem. How does it factor?
X minus 1. I mean x plus 3.
Wow. X plus 3 times x plus 1, right? Which means x equals what?
Or -1.
-3 or x equals -1. I better check these. Like they say, you better check yourself before you fail yourself. It's a new phrase. It's sweeping the internet.
So those aren't extraneous solutions, right?
Well, you better check them, right? If I plug in -3, so if I do 4 times -3 plus 13, does that equal -3 plus 4? What do you get over here? This is the square root of what?
plus 13 is 1.
So that's the square root of 1 on the left side. What do you have over here on the right side?
Equals 1.
Isn't that just 1?
1? So 1 equals 1 is just true.
Does the square root of 1 equal 1?
Yes.
So that means I can box this guy. So the other guy has to be extraneous, right? Not necessarily, right? We have to check that. So when I check the other one, is the square root of 4 times negative 1 plus 13 equal to negative 1 plus 4? So this is the square root of negative 4 plus 13, which equals the square root of what? Of 9, right? 13 minus 4. If you're 13 years old, 4 years ago you were what? 9, not 11. Over here, what's negative 1 plus 4?
3. So it's 3 plus 3.
Does square root of 9 equal 3? So that means I have 2 solutions here. Well, let's check with the graphing calculator to see. Let's see if this is true. Okay. I'm going to type in the square root of 4x plus 13 for my y1. I'm going to type in x plus 4 for my y2. Now I say that these guys are going to intersect at 2 x values, negative 3 and negative 1, right? So let's graph that and see what happens. There's my square root function, 4x plus 13. And, oh. Does it look like it intersects it twice? Well, let's do a zoom box. So I'm going to zoom in here. Here's my blue line, my blue curve. That is your square root function. Do you all agree with that?
It's pretty.
Now the red line that's going to come up here is the x plus 4. There's one intersection value, and that happens right here when x is negative 3. And then up here when x equals negative 1, you have your other intersection value. So we do have 2 intersection points, verified by the graphing calculator, your best friend and ally.